Before we start making network requests, we have to define some models that we're going to use in our request objects. We're going to use AutoValue to build our models, and this gives us a few things. First, it provides us with immutable objects, and also the convenience methods equals hashcode and toString are all overridden for us and implemented by the generated AutoValue class. This makes working with models more robust since we know our objects are immutable, and it also makes testing extremely easy since two models with the same values will have the same equals and hashcode implementation, making them effectively equal. And when working with models, that's what we're concerned with. Let's start with the user. First, we'll create a package called models. And we'll create a user class. With AutoValue, you just add the AutoValue annotation and make the class abstract. One of the fields on the user object will be the ID. And if the method name is the same as the JSON key from the response that we're deserializing from, we do not need to do anything else. Login is the next item, and this is the user ID or the GitHub user ID. And then to get that type adapter generated for us, we just have to add this static method. So when AutoValue generates a class, the implementation of the class that you define is prepended with AutoValue underscore. So this doesn't exist yet since we haven't ran a build. So let's go ahead and do that now. So now you see our error has disappeared since the object was created. Let's take a look at that object. This is actually the class generated by the AutoValue Moshi AutoValue extension, and it's extending the class that AutoValue created. Let's first look at the class that AutoValue creates for us. All this does is create a constructor that takes in the items that you defined as abstract methods and assigns them to private internal fields. And then those items are returned to calls for the methods that you defined. And here you can see we have a nice toString method generated for us. So if we print this to a log, it will be nice and readable. We also have our equals method and our hash code. So as we add fields here, these toString equals hash code methods will all be updated automatically by the AutoValue processor. Now let's look at what AutoValue Moshi generates for us. We don't need to go through all of this, but essentially it creates a way to create a user from JSON, which Retrofit will provide to it, and then a way to convert that same object to JSON when serializing back on a, say, post request. And again, these things will all be updated for us if we ever add fields. And so a lot of user errors are prevented here. If we add a field, everything is updated automatically. We cannot forget anything. So that's the big benefit of using AutoValue. Next, we'll create a repo. I'm going to go ahead and just paste in the items for this, as watching me type them out is probably not too exciting, but we'll go over each of them. So repo has an ID, it has a name, which is just a name you would expect, like RxJava. It has a description if provided, and then a repo has an owner, which is just a user object. And then we can get things like how many people have started it, how many people have forked it, a URL which will allow us to retrieve all the contributors for a specific repo, and then created and updated dates. There's a whole lot more information available in the response object, and we'll look at those objects as we make our network requests. These are all we're concerned with for now. Now you can see here, if you want to make your accessor name different from the JSON key in the response, you can do this. So this is telling Moshi that the JSON that represents this field is actually this, but we want to call it, we want to go ahead and do camel case instead of snake case. Personal preference, some people say don't mix how you represent fields from your API versus in your application. That's completely personal preference. The point is that it's possible to have your field names be different than their JSON keys. So we can go ahead and look at the generated class in here. It's quite a bit larger. So this is the class that the AutoValue Moshi extension generated for us. It's no more complicated than the user class. It just has more fields. So more fields that it has to write to JSON, and more fields it has to read from JSON. As you see, we're using zone date time to represent the dates. And the first thing we need to do actually is bring in another library that backports the Java Time API. Right now we're not getting an error because we are targeting API 26, which is Android O, where we can use the Java Time library, but that is not compatible for API levels before API 26. So we can bring in a new library that backports this API so we can use it across all API levels. So this library is the 310 Android backport, and 310 refers to the Java Date and Time API. So we'll add that import here and run a sync. Now back in our repo, we want to delete this import so we can re-import from the library. And it's going to say we have multiple options now, and we want to make sure to use the 310 backport version. I'm actually going to exclude this from auto import so we never accidentally import it. Now we're left with one option, so Android Studio just imports that for us. By default, Moshi does not know how to serialize and deserialize a zone date time. It's not a primitive type like a string or a long. So we have to create an adapter to tell it how to create from JSON and create to JSON, this type. We'll keep that in our model package. And we just need to create a class called zone date time adapter. And we need two methods. They can be called anything you want. They just need to be annotated with from JSON and to JSON. So this is pretty simple since zone date time has a nice parse method and then its toString method will just spit out the ISO formatted value. We don't have a place to register this yet since we haven't created our Moshi object to be used with retrofit, but when we create our retrofit instance, we'll be using this. And one more model for now, we'll have a contributor. So this contributor object is pretty simple. Just has their login ID, username, and then a URL to fetch their avatar. So we will be able to show a list of all contributors for a particular repo. And the last thing we need to do for models is need to create an adapter factory that we will use later when we're creating our Moshi object. Now we're going to make this abstract and annotate it with Moshi Adapter Factory. All we have to do is have a public static method. And that will return the adapter factory that AutoValue Moshi creates for us. We can run a build and see what this looks like. And so these are the static methods that we defined on all of our models. And that's why we do have to have one for each model. So what we can do with this adapter factory is register it with our Moshi object. So every time we create a new AutoValue class for a model to be used with our networking, we don't have to register a type adapter with Moshi. This will take care of it for us with one call. And in the next video, when we're creating our networking module, we'll see how that works. All right, so now we have all of our models ready. Next, we can create our networking module, which will build our retrofit object using our Moshi object. Then we can get one step closer to actually making a network request.